Hello, everyone, and welcome back to another edition of Indexer Office Hours. Today is the 6th of August, and this is Indexer Office Hours 169, the episode we've all been looking forward to, the special number. And we have a lovely POAP to represent 169, which we'll be sharing at the end of today's conversation, which I hope you guys are looking forward to. For all those who are new to Indexer Office Hours, this is the town square where ecosystem participants come together and discuss the most important and relevant topics for indexers. This is a conversation and we love participation. We love the rhyming there. We love the rhyming. And if you'd like to get involved in today's conversation will be very conversational. Yeah, I said it will be a nice back and forth. Please do get involved via voice or text, and you can do so with the text box in the corner. The conversation will be conversationing. Correct. You've got the text box, which people are utilizing with posting memes, GIFs, and all the good stuff. And if you're having any challenges unmuting your mic, let me know and I can get that sorted for you. Oh, that's cute. We missed you too, Billy. So yeah, this session will be recorded and posted onto public channels like YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. So as always, we give a shout out to the latest GRT IQ episode. And today's no different. We have Aki Bal Balo Balogi Balo. I don't know how you pronounce his last name. Nick, you're gonna have to help me out here. uh, Aoki Bal no, Balok. 𝗨𝗀𝗃𝗀𝗀. It's always the surname, but thank you for helping with the pronunciation there. And Juan, thank you for your contribution there as well. He is the co-founder and CEO of DLC Link, which is a platform that facilitates trust minimized Bitcoin smart contracts and DeFi applications. So as everyone knows, DeFi seems to be picking up on the in the Bitcoin ecosystem. So this is a super interesting conversation about some of the work that he's doing in the space. And as always, Nick goes into his background and he goes into the backgrounds of the guests, how they came to start their entrepreneurial journey, and some of the stuff that they're doing in the space, and how they're leveraging the graph. So if you're interested in any of those topics, please do check out the episode which Juan has posted, and also do check out the agenda there. Alrighty, that was a fun opening remarks and introduction. Now I will hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, Abel. Can you hear me okay?
Yep, loud and clear.
Thank you. Hello, everyone. Um, Today on the Repo Watch, starting as always with execution layer clients, we have had the new 𝗨𝗀𝗃𝗀𝗃 3 release. This is still an alpha release, but worth mentioning as we are in testing mode. So 3.0.0 Alpha 2, which uh, makes 𝗨𝗃𝗃 become evergreen. So this allows download of latest files, even if not using the latest version. And next releases will focus on chain tip performance and peak RAM usage. Maybe Payne, if you have been testing this release, let us know in the chat. Then moving on, we have a new release of Nethermind. This is 1.28.0, release candidate 0. This introduces a new RPC, which allows for advanced block simulation, enhanced optimism support, and this release also includes the ability to function as a sequencer. And it also contains, as always, performance optimization and bug fixes. And then this is all we have for execution layer clients. And for this week, this is all we have for consensus layer clients and for the graph stack. On the Launchpad stack, since we've introduced that a couple of weeks ago, we have had new chart releases for Aragon, Arbitrum Nitro, Nimbus, and Graph Network Indexer, all of these new chart versions um, update the dependencies for upstream. But then we also have a new release of proxy chart, which has a breaking change where consensus underscore aware Boolean config has been replaced by a new parameter, the routing strategy. So please make sure you update your configs when updating to using this new chart. And then for those running subgraph availability Oracle, um, we have added support for custom labels and updated dashboard to filter by namespace or network. Um, so that's on the Launchpad charts. On the Launchpad namespaces, which are just parameterized Helm files for charts, we have released new stable versions of all of our blockchains. So that's Ethereum, Gnosis, Polygon, Arbitrum, and Cello. This is specifically because of the proxy D breaking change on charts. And then we also release new versions of monitoring and Ingress. Oh, and thank you, Matthew. I was not aware of the um, new proxy. We will look into that and uh, we'll see if we can add support to it as well. All right. This is all I have for today. Thank you, Brian. Over to you, Juan.
Alrighty. Juan, you want to go?
Yeah, I was gonna say, okay, for Protocol Watch, we don't have anything to cover today. So back to you, Abel.
Yeah, I was gonna say the same thing. Okay, we've got Packer as well, so we'll hand over to Packer.
Yeah, let me just say, mainly copy pasting Juan's response. I'm presenting at Graph Builders office hours on Thursday, and I'll have more there about kind of a look back, a look inward now, and a look forward about subgraph enhancements. So, a little teaser for that, but nothing today.
Alrighty. Well, that brings us into the open discussion. So, um, as many of you know from last week, we had a conversation about Postgres and how there was a desire from many of you folks to have a conversation about Postgres questions. So we thought we'd dedicate today's session on collating questions in relation to Postgres, and luckily, in the time between last week and today, we have pulled in a few Postgres experts, so we can discuss some of those questions, have them potentially answered today. But just to let you know, we also do have a dedicated Postgres session that will be happening on the 27th. So what I have done is set up a whiteboard, which I will spin up right now for everyone to join. And on that whiteboard, we have a couple of questions. We have been lucky enough to get a bunch of questions from Jim. Jim was very passionate about this topic here, and I've pasted some of his questions here. So maybe what we can do is the first part of this, I would love to just like go through some of the questions that people have. Yes, that is how you pronounce Jim's name. I would love to go through some of I'm not passionate about Postgres. I hate it. Well, hopefully we can help out. We've got Lutter, Abhay, and a few others who said they're quite experienced with Postgres and are happy to help out. So yeah, there is a thin line between love and hate. This is true. Um, so yeah, let's maybe what we'll do is some of let's maybe go through some of the questions that we've got here from Jim, and then that will help other people jog their memory on some of the questions they have. Yeah, Jim's very diligently wrote down some of the questions. So yeah, we can get everything onto the whiteboard here, and then we can start answering questions, and building up a list so that we have something for the 27th. So without further ado, Jim, would you like to speak to some of the questions that you have here on the whiteboard?
Oh man, you're gonna make me talk. I don't like responsibilities, Abel. Don't give me responsibilities. How do I fire up this? Where's this thing?
So if you go to the
Whiteboard,
bottom,
join.
yeah, exactly. And then it should pop up. There you go. And then in the top corner, if you zoom out, can you see the questions
Okay,
up
yeah,
there?
now I can see it.
Yeah.
Yeah, so
Oh shit! Here we go
I
again.
guess I'm in the process of building a brand new graph stack that can scale horizontally, and it's like it's an in between monolithic and then going the full infrastructure as code scaling direction. That ultimately is where I will end up, but I need to go through the process of scaling up via other means, simpler means first, and then I'll move on. Part of that, or a huge part of that, is moving from a monolithic database architecture. So one physical server, a very big physical server with lots of cores running one big database, to something else which will be more representative of a cluster. So multiple physical servers, some sort of sharding, graph node sharding strategy, which, you know, it's one of my big questions is, what's the, you know, what sort of strategies have people tried? What's worked? What doesn't? What makes sense as a place to start? And I've heard, you know, lots of different opinions on that. You know, sometimes it's just, oh, well, we get to a certain size and then we just, you know, we start building a new, we add a new shard, and then there's others who look at shards that are dedicated to specific subgraphs, shards that are dedicated to providing a higher level of quality of service for specific subgraphs, stuff like that. So I'm kind of interested to hear, you know, a lot from those who have had that. I guess, you know, they both are battle tested in terms, or have got all the scars from working with Postgres, but have also got, you know, on top of those scars, they've got the wounds, which are probably still open wounds, around running upgrade indexers and, you know, of course, the jewel in the crown, the hosted service, which is, you know, a mega indexer today. So over the process of building this new stack, one of the obvious ones is the database. It's probably the most important and the most resource intensive part of the operation. So getting it right matters if you want to scale. You know, I keep saying it, but once you get into the 500 beyond subgraph counts, it's a different ball game. You know, my existing infrastructure it's creaking under the load, and performance is not good. And I'm trying to sort that out with this new deployment, or sort of horizontally scalable solution I've come up with. And as I've done that, I've just, you know, I haven't done much with my databases yet. I have moved to sharding, but with no real strategy yet. I'm doing this all on the test net at the moment, trying to familiarize myself with the daily operations of running a sharded setup, looking at what it takes to modify all of my monitoring and data and dashboards to support sharding. And these questions, and it's not, you know, exhaustive because there's things I forget to write down, but these questions all come from trying to think through how to get serious about running Postgres database. Because I think, you know, I'll be the first to admit that that we haven't really been taking it as seriously as I should for the last couple of years. You know, just throwing resources at it is not enough. And yeah, maybe we can go through some of these. I don't know, Abel, how you want to run this. This is just about, for me, this is just about sparking other people's thoughts about questions they want to ask or how they want to modify their questions here, not necessarily having a long-winded discussion about the answers unless people have a strong opinion. But we could maybe pick out some of them that are more specific to the graph, because they're not, some of them are like quite generic questions, right? You could probably go out and do a bit of research on some of these things, but I'm really keen to hear from run graph indexers at scale. And, where's the easy wins and where's the harder stuff to work on or to be aware of. Can I see the chat at the same time as having the whiteboard up?
Yes, you can.
Yeah,
So
I
if
can.
you, yeah, exactly.
I
Yeah.
think I've got it.
Yeah.
All right. So what were the ones that I think one of the things I haven't seen is, or no one's shared anything that I know, maybe Payne has, dashboards that work with sharded databases. I don't have any. I don't even know where to start right now with that. I've only just got as far as getting all of my monitoring in the new stack working. Is that trivial stuff to do, or is it very basic modification for Grafana dashboards and the queries behind them? Is it something more complex than that? What else? Yeah. One of the things that I would really like continuous visibility into is you've got a set of 500 subgraphs. Some of them are super light and some of them are just ridiculously heavy, and they take tons of time up in the database on the CPU. And I would love to be able to see which subgraphs and the activity around them are driving the most work or costing me the most, let's say, in the database. Because at the end of the day, we're running a business, right? So if you've got a subgraph that's got very little signal on it yet, it's consuming a very large portion of time in your database, then economics don't really add up. So I would like to be able to sort of see where's the time being spent. And it's not just subgraph specific, right? Because when your database gets to a certain size, again, I'm really a layman here talking, but you can see there's a lot of other sort of, what would you call them, housekeeping jobs going on in the background, and they start longer and longer the bigger your database gets and the more tables you have in the database. So I'm interested to know how we monitor those sorts of things and what to look out for. Is it typical Postgres type analysis stuff, or is it more specific to the way we use, vacuum? That's the one I see all the time, Ford. Sometimes running for hours and hours on certain tables. How bad is that? Is that normal? I don't know.
I mean, to that specific question, a vacuum job that runs for hours or even days is not uncommon if it's a big table. In general, Postgres manages it all, and vacuum jobs are pretty innocuous. The only thing is that they can eat your I/O bandwidth, right? Like what Postgres does when it vacuums is it goes through a table page by page and looks at that table and marks certain things on there. If there's been changes, it needs to write it back. So it's sort of I/O heavy, or can be I/O heavy, but that's really all there is to it. It's not a concern at all if a vacuum job takes a really long time.
Right. Okay.
There's one thing you want to look out for, which is called a wraparound vacuum, or there's so every time you start a transaction, Postgres assigns a new ID for it, and it uses 32-bit integers to keep those IDs. So roughly like 2 billion transactions. When that counter wraps around and you haven't done a vacuum on something for that long, really bad things happen with Postgres. So there's ways to monitor that, and I don't know them off the top of my head, but we have a dashboard that, I think that's what Jim is showing. That's the only thing around vacuum I would get really concerned about. I need to open that image to remember what it says. If this TXN's passed on the right, that column, it goes into the hundreds of millions. That's when you want to, that's a bad sign, because once that reaches 2 billion, Postgres will shut down. do vacuum, whatever vacuum is needed, and not do anything until that's done. But we've had 3, 4, 500 million transactions passed in the hosted service, and it sort of resolved itself. There's ways you can tweak. There's various config settings, how you can tweak vacuum, like how many vacuums can happen at once, and how fast vacuum can write data to disk. But I would have to look up what like settings are that we use, and I would defer to John on that in the Postgres workshop. What sort of the right guidelines are for setting that.
It's also
don't fear the vacuum. Like it's not generally not a huge problem.
I think thank you for that. One of my biggest concerns is, and is as we will get into more detail, I guess, on these things on the Postgres workshop. What's the name of that quantum? Is it the quantum effect? When you measure something, you change it, sort of thing. Sort of rough analogy to going into your PostgreSQL.conf and sort of changing things, and then changing things to the point where you completely screw things up, or not really knowing whether a change you made has helped or not. It seems to me that when you make these changes, you need to make them with a view to understanding what with a view to being able to measure the outcome, right? Whether it's improved situation or not. And I think for me, I've changed a few things in Postgres. I've changed a few things related to the ZFS in Postgres. I've done things like increase connection sizes, and in order to stop things from falling over. But I know that that's not, a be all end all. You're not supposed to just keep increasing those numbers.
But keep in mind that the default Postgres configuration is very, very, very conservative. Right. Like roughly so Postgres runs well on a Raspberry Pi type thing.
Right.
So if you have like a beefier box, 32, 64 CPUs, hundreds of gigs of RAM, there's quite a few things that need to be bumped up.
So how many shards roughly would the hosted service be running to support? I don't even remember the number now, Lothar, in terms of subgraphs. It must have been an absolutely huge number.
Yeah, and we're actually fighting with a huge number right now. It's like something like 36K subgraphs in I want to say about 20 shards. And, those shards are pretty monstrous databases. Although we're in the process of downsizing some of them, because what we've seen with the Sunrise is that query load has gone down quite a bit, because way more stuff is in the network and everything goes through the network. And so I actually haven't pulled the latest traffic numbers, but I think the hosted service traffic is sort of lower than it was before the Sunrise. If you look at sort of, there's two things we do with the database. Very obviously, we write to it and we read from it. In terms of resource consumption, queries are usually the biggest user of CPU by a large margin. And so if query traffic drops, your CPU utilization drops. And when you see CPU utilization really high on the database, that usually means that there's usually it's just like one or two queries that are really, really slow, and you're getting a lot of them.
Yeah.
That's where looking at that query and adding an index can have a huge impact. Like I've seen cases where database shard is at almost 100% utilization. You add an index, and it drops to 40%. Like just by having one index. There's also this account-like optimization that you can turn on with Grafman, which is very good for tables that keep lifetime statistics for Uniswap type subgraphs. That's token, pair, pool. Those tables, we usually always set them to account-like, and that has a huge impact on CPU utilization. On the right side, I think from a database point of view, where you see stress there is that your I/O bandwidth to disk is pretty much saturated. A big part of that is because we do something really stupid with database indexes. By default, we create an index on every attribute of every entity because we have no idea what queries we'll get later on, right? Like because we're in this process of we're syncing a subgraph and we're getting no queries for it, and then once it's synced, we get lots of queries, and we don't know what the queries look like, so we just create all these indexes. But once a subgraph has gotten a certain number of queries, there's ways to see which indexes are actually used, and dropping indexes can help a lot in lowering the write load. Because every time you write to a table in Postgres, you also need to write to all the indexes, so you have sort of pretty bad write amplification because of that. And I would love to have a better indexing strategy than just create tons of indexes. But if we don't do that, you'll have to do a lot more manual stuff as soon as you get queries, right? Because without all those indexes, some of them will be used a lot, some of them not at all, and but we don't know which ones.
Yeah, that's really interesting. Thank you. One of the things that I was interested to understand a bit more, this is really second to that question, but it's, I understand there's a lot of caching functionality in Postgres, but is there, I don't know, Luther, if this is something you would have an answer for or would want to answer on, but is there any caching going on at the proxy level? So at the gateway in terms of the queries that would take load off the database, or do you really leave Postgres to handle any caching that can be done based on the queries that are coming in?
Yeah, the gateway doesn't cache, but GraphNode does. GraphNode has some caching built in. I actually wrote not too long ago. Let me see if I can find that real quick. Somewhere. Yeah, I'll dig up. I wrote up a gist about how the caching in GraphNode works. Yeah.
Is that why they get so? That's why they're memory hungry. Is that one of the reasons why they're quite memory hungry when they get busy? Those query nodes.
No. What was the memory hungry thing? God, I forgot. Like a while ago, like 3-4 months ago, I rolled out a change, and memory. Like on our query nodes, the memory went from, I don't know, 200 gigabytes to like 20. And when I saw that, I'm like, oh, holy cow, I've broken something really, really bad. But it was, I forget what the change was. Maybe it'll come to me.
They used to sort of, I don't know if it's a memory leak, but they used to really creep up very slowly, if I remember.
It wasn't it wasn't really memory leak. It was more memory fragmentation. That we created all these little bits of free space, and then large queries came in, and the only way the query node could give us a big chunk of space, a big chunk of memory was to expand the memory it was using. But I'm totally blanking on what that change was.
Just to go back to the sharding strategies that have you tried different sharding strategies in the past, or is there a strategy associated with that 15-20 shards, or is it simply a matter of you look at the the usage metrics and make a decision on whether you need another shard or can reduce the number of shards you have?
Yeah, it's mostly so what we do is we have one primary, which should only have the metadata, and the primary can be a pretty small database. For historical reasons, in the hosted service, it's still really big, but I would guess 4 CPUs, 64 gigs of RAM, or probably less than that, should be enough for the primary database. And then we have couple databases that have the block caches for the chains, and then all the other ones are just subgraphs. And we try to be clever about how we allocate subgraphs to database shards. but for the most part, yeah, there's no really great strategy. So we basically put subgraphs round robin into those shards, except for a couple things where we know we're getting a lot of query traffic. And we have some deployment rules for like, if the name is this, which of course with the sunrise doesn't work anymore. If the name is this, put it in that special shard. That would be my advice. A small primary, separate shards for the block cache, and then I would start with just putting subgraphs sort of round robin in other shards, or like start with one subgraph shard, add more as you need it, and if you see that a specific subgraph gets like 20-30% of the queries, and the shard it's in is under a lot of stress, I would set up a dedicated shard for that, or maybe put a few, but a handful of subgraphs in there. That's sort of the strategy we use.
That sort of config is achievable expressed through the graph node config toml. Is that correct?
Yeah.
So everything you've just explained can be expressed via that toml file.
Yeah. Mm-hmm.
And if I already have a database, so I've just started up a do one and I'm syncing a bunch of horrible subgraphs, I can basically can I use Graphman to sort of shuffle the deck chairs about so that I have a small primary with only the metadata to block cache or a block cache.
Yeah, you can
shard.
you can use Graphman copy to do that, to move subgraphs around, and it has I think the option's called on sync. So if you just do Graphman copy, you'll wind up with two subgraphs that are the same and that get indexed and all that in parallel, basically. Although they can progress at their own speed, so you can have like a couple blocks difference between them. But there's options you can pass to Graphman copy that basically say, once you're done copying and the subgraph, the copy is caught up with a chain head, get rid of the old one.
Got it. And
so you move.
You can move more than just subgraphs, right? So I can move the block cache to a
No,
different
we
shard.
don't have any tools for the block cache.
Okay, so that's a decision you need to make when you're first deploying.
Yeah,
Got
we
it.
probably should have tools for that, but as far as I know, we don't really do anything there.
So when you say the primary is left with metadata, what is that? What sort of data are we talking about there?
It's mostly like a directory of all the deployments and all the chains you have.
Got it.
So there's a table called deployment schemas that is an entry for every deployment you have, and it says, oh, the actual data for this lives in this shard. And then also for the chains, there's a table called chains that says, mainnet lives in this shard and whatever other Arbitrum mainnet lives in this other shard. And the other metadata it keeps is the mapping of subgraph names to deployment IDs. So all the data is really, really small. And like we're talking about megabytes of data that make up the primary.
What was that last one? Sorry, it's a subgraph name. So that's the agent, the indexer agent aware name versus is it the table name for the subgraph?
Versus the IPFS hash, right? Like a name can point to different IPFS hashes over time. And so when we get a query for a specific subgraph name, we first need to find the IPFS hash, and that information is in the primary.
Got it. Okay.
And there's in the graph node repo, there's a docs implementation directory. I think it's in there, and there's a file called metadata.md that explains what the metadata tables are. There's also metadata that gets stored in the shards themselves. Like, for example, the subgraph head pointer for each subgraph is stored in the shard where the subgraph data lives, just because that needs to move in sync with the actual data. So you can think of the primary as basically a directory of what you have and where the actual stuff lives in which shard.
Mm-hmm. So your map is basically in the primary and is
Yeah.
Pretty simple. The block caches, so every chain has a block cache. That's correct, right?
Yeah.
And typically you put all of your block caches in one place, or you mentioned 2 shards there.
Yeah, because the hosted service has so many chains. I'm not even
Yeah.
sure how many, but a ton. We're running 2 block caches.
Yes. I mean, I've covered a few of the top ones there. I don't want to spoil things for the workshop. Able.
Yeah, I mean, John is a much better person to talk about the specific, like what tables keep like IO stats in Postgres and stuff like that. I mean, one thing, so to find slow queries, there's 2 things I usually do. One is we have a dashboard that just shows the queries that are going on in the database based on the pgstat activity table. Like pgstat activity just shows all the queries that are running right now in Postgres. And if you really have slow queries, you usually have a lot of instances of that. It's fairly obvious which one the slow query that's going on right now is. And then there's pgstat statements, which sort of has accumulated metrics about query performance. And so if you want to know which query was the most costly over the last however long you've been collecting statistics, you can get that out of that table pretty easily.
Do you use any third-party tools? There's a lot of stuff out there, I know, in the Postgres world. Do you use anything third-party to do any sort of analysis? There's lots of companies out there that promise the world when it comes to these things, or do you find that the fundamentals are really...
Yeah, we're basically using the fundamentals. I mean, since we're running in Google Cloud, they have a few dashboards, and they have like a very nice view essentially into pgstat statements. So we use that, but we don't really use any third-party tools, but it's something we should probably be looking more into. And again, I think John has experience with what people usually do there and which tools are good.
This is great. This is great. I've been looking at the chat, and there's quite a few. Yeah, always a super useful discussion. I've been looking through the chat, and I can see there's a bunch of questions. And Ford is going through them and answering them, which is phenomenal. Yeah, keep the questions coming. We want to get all of the questions down. I mean, yeah, luckily we have Lotta, who's doing a great job of answering them, as well as Ford. But yeah, keep them coming, because we want to make sure that the workshop that we have on the 27th is tailored towards what you guys are looking for. Are there any questions that are still unanswered in the chat? I believe Ford is going through each and every one of them, but if there's anything that we want to cover, yeah, let's go deeper. Let's see.
Can I just make one comment maybe on the workshop, Abel,
sure.
before I shut up?
Sure.
Just trying to think with a sort of user-focused, customer-focused head-on. I think, again, this is my opinion, but whatever we do in that workshop, there should be some practical element to it. One of the best examples there would be, how do we, what's the process, or let's work through the process for diagnosing a slow query, right? Like some kind of objective in the workshop where we work through a practical problem, or we see how the experts work through a problem so we can learn to do it ourselves. With the end goal being improving the service at the end of the day, right? So I have tons of queries in my database that get dropped because they take longer than 2 minutes to run. So first question, are they queries that I should be running? Is my customer getting pissed off because they get tons of failed queries? Is there something I can do to improve the performance for my customers so that they're getting a better service, right? So I would like a line item somewhere where we walk through that specific, because this is quite time consuming, right? But I think if we had something recorded that we could point to for indexers to say, if you want to try and, optimize for performance problems you're having right now with specific queries, here's how you find them, here's how you analyze them, and here's how you fix the problem. That would be super, super valuable.
That is
Yeah.
a phenomenal suggestion. So you mentioned diagnosing a small query there as one of the practical things that we could potentially do. It'd be great to get a list of things, in your opinion, and also other indexes of things that we could do, and then maybe I'll put those to the folks who are going to be doing the workshop and see which ones they can potentially do, and maybe we could do we could extend it to multiple sessions where we do let's say 3 over 3 sessions. So you mentioned that one. Is there any other ones that you'd like to, any things that you'd like to do from a practical perspective?
Yeah, the other one would be, and maybe Payne can help with this. I don't know.
Sorry, go
what?
ahead.
There's a little bit of paralysis for me around moving from how I do config TOMLs today versus where I want to go. And, I need that little, I don't know, spark of seeing someone else and how they've done it, maybe talk through how they've done it to get me started. So maybe walking through how you've done, or, like a basic sharded set of TOML files or single TOML files, however you want, you do it, to give a starting point for people who want to move from the monolithic to the sharded framework. Does that make sense?
I can definitely help with that, but I was just wanted to say that I also second your thoughts on like the process of like finding those slow queries and addressing them, because right now, even though I have a sharded database, I have absolutely no fucking clue what's going on in those databases, and I know I have like a ton of slow queries that I don't know what to do with them.
Mm.
Like I see them and I basically what those screenshots that you posted above with like those slow queries and everything, I see them too in my database, and I have absolutely no clue what to do with them.
Yeah, that's my shame. That screenshot. It's that's not even it gets worse than that. It gets worse than that.
I have the same.
And I really want to fix it. I want to be able to say that we're optimizing performance and making things better on the network for our customers.
Yeah, 100%.
And I just also want to, put a big signal on getting Derek involved in this, because I know he's put tons of work into spreading the word on both performance, both from the subgraph developer point of view and the indexer point of view. So if he was able to get involved in that workshop around analyzing and improving query performance, that would be really great.
Yeah, for the screenshot, the two like in our dashboard that shows active queries, we actually have a toggle to suppress auto vacuums, because who cares? The first query in there, that update, that's from a revert, and yeah, unfortunately they tend to be really, really slow, and I haven't really gotten to a place where they become faster.
I can show you examples of like very, very slow queries as soon as I turn on my query node.
It would be great to build up a library of examples, where somebody could look at what they have going on in theirs and correlate it roughly to something that's been talked about in a workshop. That would be really great to see.
This is amazing. I'm writing all of this stuff down, and I'm actually thinking that there's a lot here that we can do. So it's probably going to be a multiple IOH kind of a thing, because there's a lot of stuff to digest here and go through. But this is great. Yeah, keep it coming.
Can we make that workshop like last a little bit longer than 1 hour? Because I fear that we don't have enough time.
Or we plan a set of them, Abel, just so not to sort of encroach too much on people's calendars.
Yeah, sure. I'm definitely leaning towards kind of doing multiple sessions. Maybe like a part 1, part 2. would that
Three,
would that
four,
work for
five,
you?
six. I'm serious.
Yeah.
I mean, this is
+1 to that.
Okay.
maybe a theme. Maybe a theme. Abel,
Yeah.
we don't need to take up all of IOH's time every time, but there's a theme here, which is, getting very serious about delivering performant APIs, and I think we should prioritize it, but it should not take over the spirit of IOH. If that means something else needs to be scheduled, then maybe that's what we need to do.
Yeah, no, we can definitely weave it in to IOH. It's definitely the venue to talk about these kinds of things. But okay, the message is loud and clear. 679. Some people are even saying 69, 420. We should do a lot on this. Okay. And yeah, I'm happy to schedule a bunch here. So yeah, this is good to know. Yeah, I mean, it sounds like yeah, Derek is at a then disappointment today, but maybe if he's around next week, I can try to get him to demo, and then the week after could be the workshop, and then I'll think about other things that we could do after that as well. But yeah, I do like thinking that it's a theme about yeah, performant APIs and yeah, making them reliable. Okay, cool. Yeah, any more questions? Keep coming. We've got 10 minutes, so like I would love to get as much information that I could forward on to folks so that we can prepare for the sessions upcoming. Oh yeah, and don't forget the Power App as well. The most awaited IOH. There you go. And we've got a cool new design as well for today's Power App, which I'm excited for you guys to see. Nothing too crazy, It is episode 169, but there is no crazy Power App. It is a safe for work Power App. Don't worry. But it's a nice design to Power App. So yeah, enjoy. And yeah, keep the questions coming. Would be keen to hear more as well.
Unrelated, but again, coming across all these different challenges as I start to scale things up. I'm noticing that when you scale up your service nodes, they absolutely hammer the queries against the network subgraphs. Has anyone else noticed that? I'm testing 8 service nodes at the moment on the test.
Yeah, every service node basically has to run independently. So yeah, you're gonna like linearly increase the number of queries towards the network subgraph, unfortunately.
I was thinking about, like, I don't even have an 𝗨𝗀 𝗟𝗶 node. That's my big problem right now, because I think both the epoch and the network subgraph are both on there, I think. So I can't sync them without having a 𝗨𝗀 𝗟𝗶 node, which just seems ridiculous to have one of those just for a couple of subgraphs. I mean, obviously, Payne, you're noticing this too. Have you tried anything like caching? I was thinking about maybe if I put my Infura, maybe I shouldn't say this on a recorded call. Is it? No, there's nothing no, this is fine. About maybe putting my Infura API URL or whatever behind dshackle and then a Redis cache or something. I don't know if anyone does things like that. Maybe if I was to cache the queries and they're all making the same query, then maybe that would cut down the amount of traffic I'm using straight away. Don't know.
But like, aren't you like, wait, you don't have an Arbitrum node?
I don't have an Arbitrum 𝗟𝗶 node.
I just run in prod, dude. Come on.
Well, yeah, I was actually having a conversation with someone about that, and I thought, why don't I just take 100,000 GRT and run it on mainnet, because I've got all that infrastructure already. So yeah, that's on the tables as well. But it's nice to be able to run on testnet and, no monetary consequences. But it's just those nodes are so expensive to run, for very little.
Isn't Pinax running a 𝗨𝗀 𝗟𝗶 node you can hit? Hopefully. Yeah, there you go. Problem solved. But yeah, you would still need a caching layer, especially if you scale up those service nodes. Question regarding those, like scaling up those service nodes. At what point do you need to scale? Like how many queries per second does one of them take before becoming slow or like, yeah. I don't even know what the question is, but yeah, you get what I mean. Ford, maybe you can help. Lol.
Yeah, I mean, we're running in the hosted service. We're running. We segregate traffic in a proxy for like high volume stuff, but I think that with a sunrise is sort of pointless too. For general queries, we just have 2 query nodes running. And I think after that change I mentioned that I don't remember what it was, that they're not even that huge, like maybe 64 gigs of RAM.
How many indexer service nodes are you running for the upgrade indexer?
A lot more. 15 to 20, something like. Oh, indexer service, that I don't know.
Yeah.
I'm talking about query nodes and index nodes.
I had a conversation. Is Marc-Andre on today?
No.
No, okay.
He can't make it. Yeah.
I'm sure he won't mind me sharing. I had a conversation with Mark a week or 2 ago because I was trying to, look at sizing my new horizontally scaling stack, whatever. And he was suggesting that with the indexer services, you want to run more of those than your query. You don't want to do a one-to-one sort of queries to services because caching's more efficient on the query nodes if you have less of them, right, with more memory. And he also mentioned that with the indexer services, because it's a Node.js process, he tries to make sure that the CPU on them is never pinned, right? It's always, on average, the system load is well below 100%. I guess that's something to do with some properties of performance with Node. So I'm sort of working off that at the moment, Payne, in terms of where I'm starting. Because at the moment I run one service node and one query node, and they're just dead. Oh, interesting. Monitor the latency added by indexer service. So can you see the latency broken down by where it is in the, I guess, the chain of delivering a query?
There's improvements in the works to make that a little better. There's we don't have all the detail of every step because putting metrics in there would add latency to the query path. But we do have metrics in the indexer service for overall query execution time and for the more specific response time of the graph node. So you can compare those and see how much latency indexer service is adding there. So yeah, I often look at a dashboard we have for that. And then same things you were saying, definitely don't want indexer service to get CPU constrained because the node runtime isn't great at handling that. It would lead to blocking and cause issues. So you definitely want to keep your CPU load down. And in order to do that, yeah, we scale it horizontally. So as I mentioned there, we use Kubernetes, we have a stateful set, and right now it's scaled up to 10 pods. That sometimes changes depending on load and what we're seeing in monitoring.
A follow-on question to that, and maybe this is just obvious to the cubes heads in the room, but maybe not so to someone who came from the bare metal world. I forget which endpoints it is now, but your sort of endpoint between the service nodes and the gateways. I assume that's load balance. Well, that's load balance, right? But then also the connections between the internal connections between your service. What did you call it? Pods. Stateful set, whatever, 10 of them. Those connections then onto the query nodes. So the query nodes are, I assume, also load balance. There's a load balancer between them and the service nodes. Is that right? Is that how you're doing it?
Yeah, so in Kubernetes land, basically you typically use what's called a service. So you have the concept of deployments and you have services. So for the query nodes, you'd have maybe a stateful set of query nodes or maybe even multiple, and you'd have a service that allows other deployments in your Kubernetes workloads to hit those query nodes. So basically, TLDR is a load balancer on top of the query nodes, but it's internal to our Kubernetes setup.
Got it. As per usual, I'm just re-implementing cubes outside of cubes, and I will eventually end up with cubes.
All roads lead to
I have to take this
cubes.
path forward. I have to take this path. I have to take the painful path to learn. Otherwise,
I will be patiently waiting in cubes land for when you arrive.
Yeah, I think a few people are waiting.
I love it. I love it. Cubes. Everybody gets a cube. We're all going to be in cube land soon. Okay. We are running up on time, but I also want to make sure everyone, or Ansible Planet, I want to make sure that everyone's uh, questions are noted down. I've been diligently writing down all of the things that have been spoken about, and hopefully some of them have been answered. We're lucky enough to have some experts join us today and answer them, so really do appreciate that. But yeah, if anyone has any questions that they want to note down before we wrap today's conversation for the workshop on the 27th, please do. I really like the idea that Jim Payne and Jim have proposed around doing something practical. So we'll work to try and get that sorted. And yeah, we'll also reach out to Derek as well so that he can. It sounds like he's down to do a demo for the Data Nexus Postgres setup. So we'll try and see if we can get that sorted for next week. But yeah, last call for questions, thoughts, final before we wrap today's conversation. Okay. All right. Well, in that case, it seems like we are good on the question front. Want to thank each and every one of you for showing up today. This was a very informative session. And yeah, I've learned a bunch, and it sounds like there's real appetite for a theme that we can continue going with, going forward because yeah, there's real appetite for this. So yeah, we'll work to try and get this sorted for the coming weeks. And yeah, looking forward to helping everyone with Postgres stuff so that we can level up. Thank you, everyone. And we look forward to seeing you all again next week, where hopefully we'll have Derek demoing the Data Nexus setup, provided schedules permit that.